Welcome back to GLASP Deep Dive, short takes on the long reads worth your attention. I'm Hope, and today, an AI coding workflow that felt like pure magic and quietly stopped working after about a year.
And I'm Adam, and almost nobody noticed the moment it broke. The magic just got a little less reliable each week, until one day you're cleaning up after your own assistant.
Let's start where it started, vibe coding. Karpathy posted this in early 2025, and it read like a joke. His line was, "I just see stuff, say stuff, run stuff, copy-paste stuff, and it mostly works."
And the key phrase is mostly works. Because it did, for about a year. Point a model at a fresh app, accept whatever it gave you, barely read it, ship something real.
Then the bill arrived. Forrester research last year found code with serious AI involvement carried roughly 1.7 times the rate of major issues. And security audits put AI-written code with flaws somewhere between 40 and 62%.
Even the low end is bad. Models hallucinate APIs, skip validation, leak secrets into logs. And what broke wasn't the model getting worse. It was the assumption underneath.
That one prompt and one context window could carry a real codebase with 5 years of decisions baked in. The cracks showed up 3 ways. First, the model forgets your conventions mid-session and reintroduces patterns your team spent months deleting.
Second, long sessions fill with so much junk, the model ignores what you actually asked.
And third, the scary one. Agents happily run destructive commands because nothing stops them. You say, "Do not push to main," and it works about 95% of the time.
Which sounds great until you flip it. 95% means it fails 1 session in 20. You'd never accept that from a deploy script. And by late 2025, every serious team had quietly built the same scaffolding. Same shape. No name yet.
Then Karpathy posts again, about a year later, and names it Agentic Engineering. So what's the actual shift?
Vibe coding described the toy mode. Agentic engineering describes what people who actually ship are doing. The model's still doing the typing. The human moved up a level to engineering the system the model runs inside.
And the old job was prompt engineering. Optimize one string of text. Martin Fowler called the new job context engineering. What the model sees when it sees it, and what it can do with it.
And it's not one tool's idea. Cursor calls them rules and background agents. Copilot uses an agents file. Gemini has its own. The names differ, the shape does not.
So here's the shape. 4 pillars. They look interchangeable, but each solves a failure mode the other 3 can't touch.
The clean way to say it? CLAUDE.md is what the model knows. Skills are what it can look up. Subagents are who else it can ask. And hooks are what it cannot avoid.
Knows, looks up, asks, can't avoid. Let's take them one at a time, starting with the file.
So your CLAUDE.md file, just markdown at the root of your repo. The agent reads it at the start of every session as background context.
And it's not memory in the consumer app sense. It's the file you write to tell the agent what it would have learned if it had been on your team for a year. Stack, layout, safe commands, the hard rules, domain terms.
And there's a trap almost everyone hits. The Everything Bagel Claude file. 4,000 lines. Every decision you've ever made. The model loads all of it and treats the relevant 5% the same as the irrelevant 95. Adherence to the rule that matters tanks.
So it's closer to a sticky note than a wiki. One screen of essential context. And here's the tell. If a section starts with, "When doing X, then X wants to be a skill."
Perfect handoff. CLAUDE.md is for always true. Skills are for true when.
Which answers a question I get constantly. What's the difference between a skill and just putting everything in the Claude file?
One word. Loading. The Claude file loads at the start of every session, always. A skill is a small markdown file that loads only when its description matches the task in front of you.
So if you cram steps for 10 tasks into the Claude file, the model loads all 10 every time, and adherence drops. Skills keep the file tight, details on demand.
And the model I like. CLAUDE.md is your colleague telling the new hire the basics on day one. A skill is the runbook they hand you when a payment webhook fails at 2 in the morning. You read it when you need it. You don't memorize it.
Good skills are narrow. How to rebase cleanly. A billing integration checklist. And they compose. The agent can pull 3 into one task without you predicting that combination.
One craft note that bit us early. The description matters more than you'd think. Vague ones either never fire or fire on everything. Helpful for code things means nothing.
Right. Name the situation instead. Use when the user asks to rebase a branch, resolve merge conflicts, or clean up commit history. That's a trigger the agent can match against. Pillar 3. Subagents. The one people misread the hardest. What even is a subagent?
An agent the main agent can call. Its own prompt, its own context window, its own tool permissions. It does one job, returns a result, then it goes away. Clean room, one task, done.
And people hear subagents and think parallelism. Cursor does advertise up to 8 background agents. But that's not the main point.
Parallelism is a side benefit. The real prize is context isolation. Keeping a risky or noisy task from polluting your main context window. 3 patterns make that concrete.
The researcher. You want the agent to read 200 files and summarize. If the main agent does it, all 200 land in your context when you only needed 3 sentences. A research subagent reads them and returns 1 paragraph. The answer without the haystack.
The reviewer. Before a commit, you want a fresh pass on the diff. A reviewer subagent loads a code review skill and reads the diff with no other context.
And here's my favorite property. It has no memory of the implementation argument the main agent just had with you, so it can't rationalize the problems away. No ego in the diff. It sees what's there.
And the risky operation. A migration, a bulk rename, a schema change. The agent runs it in isolation and reports back. If it goes sideways, the wreckage is contained in that subagent's context.
Now there's a real cost. Every subagent is another model call and context window, plus coordination overhead. Spawn 1 for every tiny task and you'll burn tokens and slow down.
Right. So when do you reach for a subagent instead of just writing a longer prompt?
3 conditions, you only need 1. The task would dump garbage into your main context. Or you want a fresh perspective the main agent's reasoning can't taint. Or it's risky and you want it sandboxed. Otherwise, a longer prompt is the better tool.
Which brings us to the pillar I think is most important and most skipped. Hooks. The part of the stack the model literally cannot talk its way out of.
A hook is a shell command wired to a tool event. When the event fires, the command runs, and the model has no say. A pre-tool use hook fires before a tool call and can block it. A post-tool use hook fires after.
And there's a stop hook that fires when the agent finishes a turn. Great for notifications. But the headline is why hooks beat prompts for safety. Prompts are probabilistic.
Even a crystal clear instruction like, never run a destructive delete command, fails occasionally because the model is doing pattern completion. It's guessing, very well, but guessing.
Whereas a hook that greps the command for that delete pattern and exits before the shell ever sees it fails 0% of the time. As the article puts it, it's a regex, not a vibe. That one line is the whole pillar.
3 hooks worth having. A pre-bash guard that reads every command and blocks the dangerous patterns. A destructive delete. A force push against a protected branch. Overwrites of your environment files. 30 lines of shell saves you from disasters prompts can't prevent.
2. A formatter on save. After the agent edits a TypeScript file, run prettier automatically. Deterministic, no nagging. And 3. A notification when a long task finishes, so you can let it run for 10 minutes and not babysit it.
Now the obvious worry. Don't all these hooks slow things down? You're firing them constantly.
Each hook is a process spawn, so it adds milliseconds to maybe a second, but it's completely dwarfed by the model's own latency. The one caveat: a hook that runs your full test suite on every edit will feel sluggish. Those expensive checks belong in CI.
And that's the real shift. Stop thinking of safety as something you ask the model to do. Think of it as something the environment enforces, like CI enforces tests. The model's a fast junior. Hooks are the pre-commit check it can't disable. So let's watch all 4 fire in one session, because that's where it clicks. Picture an 80-line Claude file, 6 skills, 3 subagents, 4 hooks. And the developer just says, add an API route that returns user bookmarks. The whole prompt.
The agent reads the Claude file, matches the add an API route skill, loads it, writes the file. The post-edit hook quietly runs prettier. It writes a test, prettier runs again.
Then it hands the diff to the reviewer subagent, which flags missing input validation. The main agent adds it. Developer says commit. The pre-bash hook checks the branch and allows it. The stop hook pings them.
And notice, no part of that needed a long prompt. The prompt was 1 sentence. Everything else was wired into the environment. Honestly, the agent that built this show runs on that exact scaffolding. Now the anti-patterns, the ways people adopt this badly and conclude it doesn't work.
The one giant Claude file we covered. The rule that matters ends up buried under 2 pages of rationale, and the model picks up the rationale and forgets the rule. The no hooks bet. Some teams rely on prompts to stay safe. It works most of the time, which is exactly the problem. Lose an hour of work? Fine. Drop a production table? You needed a hook.
Subagent sprawl. A subagent for every conceivable role. Researcher, reviewer, planner, summarizer, namer. Each is another file, more tokens, more coordination. 3 to 5 with clear jobs beats 20.
And 2 cousins. The skill that's secretly an 800-line wiki dump, which loads all 800 lines every time. And treating skills like the Claude file.
Right. A team-wide rule in a skill only loads sometimes. The rule, never use this package manager, applies to every task, so it belongs in the Claude file. Wrong pillar, wrong outcome.
Which is the through line. The leverage isn't in volume, it's putting the right invariant in the right pillar. Always true in the file, true when in a skill, isolated work in a subagent, must happen in a hook.
So let's make it actionable. If you're still in pure vibe coding mode, what's the lean version you can stand up this week?
A 50-line Claude file, stack, package manager, and which to never use, top directories, 5 hard rules, a few domain terms. Then 2 skills, rebase cleanly and review changes.
1 reviewer subagent that loads the review changes skill and runs before commits. And 3 hooks. Block the dangerous commands, run prettier on edits, ping you on finish. Maybe 8 files, all in version control.
And you'll iterate. After a week, you'll notice the tasks the agent keeps fumbling and codify them as skills. The 4 pillars are the shape. The content is yours.
And here's the line to leave people on. The shift from vibe coding to agentic engineering is not a step up in cleverness. It's a step toward operational discipline. You treat the agent like any other system that runs in production.
Conventions, guardrails, isolation between concerns. The work is making the model boring, more predictable, more constrained, more reviewable. Less magic, on purpose. That is the work. Want to go deeper? Full articles on glasp.co. Just search Agentic Engineering.
See you in the next deep dive.